Well, sunsets are red, the sky is blue. If you ever wondered why, well, this is a lesson for you. Welcome to the WeatherFirst Workbook, everybody. I'm WeatherFirst Meteorologist Nick Stewart. It's some of the most common questions that we get about weather. Why is the sky blue? Why are sunsets so colorful? And of course, those brilliant arcs that you see in the sky, rainbows, how do they form? Well, to answer all those questions, we're going to start talking about rainbows. Again, rainbows, you need two things. You need the sunlight as well as you need the rain falling. Here's a picture from Center Point, Iowa, back on Independence Day last year. You can see the big arc in the sky there, the brilliant colors that you see. That is a rainbow that's caused by the sun passing through all the rain droplets that are passing through the sky. The rain droplets act as a prism. Now, to illustrate exactly what's happening here, I have a little experiment set up with my own little prism, little piece of glass. So if we dim the lights down in the studio, what we'll do is we're going to create our own little rainbow here using this piece of paper. It's a little dim. But what you can kind of see on this piece of paper is that as the light from the flashlight is passing through the prism, it's actually being what we call diffused into multiple different colors. You can kind of make out there the red on the far left edge and the indigos and the violets on the bright side there on the far right side of that. And that again is the prism taking the light coming into it and diffusing it into multiple different colors. Now what you can't see going out of the prism is exactly what the light is doing. But it's 2020, we have the technology to do just that. So we're going to use a laser pointer instead. We're going to tilt the prism on its side, and then we're going to shine a laser through it. And what you're going to see is that the light is not just, let's see if we can get it to work there, little dim, but what we can kind of see there is that the light is passing through the prism and it's bouncing multiple times inside. Let me see if I can get this a little bit better. This is on 5. You can kind of see that it's it's kind of bouncing multiple times throughout the prism. I'm going to zoom in on this camera here. And you'll kind of see, if I can tilt it the right way, that's a little better. You can kind of see how the little lines there of the laser are shining multiple times throughout the prism. Basically, the light is what we call reflecting inside the prism multiple times. So to better show this, we got some graphics, of course. We're talking about why exactly lights form. So let there be light again. And here's kind of a look at the graphics. Why do rainbows form? So the sunlight that comes from the sun, it looks white to us. However, that light is actually made up of a series of different colors. The reds, the oranges, the yellows, the greens, the blues, the indigos. All of that light is coming from the sun. It looks white, but it's actually made up of all these different colors, the visible colors that we see. Now, when we get a thunderstorm to form, we get rain droplets to fall from the sky, and those little rain droplets, they act like little tiny prisms. So what happens is the white light enters the rain droplet. That light then does some internal reflections inside of that rain droplet, and all that white light is diffused into all of its normal colors. So the red, the orange, the yellow, the green, the blue, the indigo. That's what's happening inside of this, and that is why you see a rainbow. The white light is broken up into its multiple colors. Now what happens, again, in terms of the technical terms, is that the light enters a rain droplet. We have a process called refraction, where the light enters and it begins to bend. Now the different colors, they have what's called different wavelengths. So they bend at a slightly different angle than one another. So that light bounces inside, that then reflects off the inside of the rain droplet, bounces inside of the rain droplet, and then again it refracts again out of the rain droplet, bending back. And again, that's why you see the rainbows form, because you see the colors essentially get broken up. Now here's video of a rainbow that we saw here at Broadcast Park last August, and you'll notice that there is what we call a double rainbow. You see 2 rainbows in that video. All that's really happening there is that instead of 1 reflection inside the rain droplet, there are 2. And that's why the second rainbow, the double part of the rainbow, tends to be dimmer, because more of the light is already getting reflected through the first rainbow, and there's less light to see it happen a second time. So you really just need a very bright sun that's very unobscured by rain to see those double rainbows. Now the other common question that we see, why is the sky blue? That's a very common question that we get. Here's a live look right now over Coralville, down in Johnson County. You can see the flags waving there, but more so look at that blue sky, that very picturesque blue sky, nothing really going on, no clouds in the sky at all. Well, why do we see that blue color in the sky? Well, it's a very similar process, kind of anyway. Again, the light that comes from the sun, it's that white light. We see that it's multiple colors though. It's made up of that visible colors. Again, the reds, oranges, yellow, greens, blues, indigos. All of that is coming through our atmosphere. So here we kind of the planet Earth here. Here's kind of our fictional atmosphere above the Earth. All that visible colors passing through the upper levels of our atmosphere. However, as I mentioned earlier, kind of alluded to it, the colors are made up of different wavelengths. So the reds, really long wavelengths. Think of an ocean where you have these big waves going through the ocean. Meanwhile, the blues are very small wavelength. They're much faster waves. They're much smaller waves that are dancing much faster. That is very important in terms of why we see the sky that is blue. So what's happening here is that our atmosphere is made up of all different types of molecules. In case of why we see blue, it's interacting with the nitrogen, the oxygen, the air that we breathe. The color sunlight is interacting with all these different molecules here. And as the wavelengths pass through the atmosphere, you'll notice they're also interacting with all those little molecules of gas in the air. And so what we're seeing here is that the reds, the yellows, the greens, they don't interact with them as much. They're kind of missing those air molecules in the sky. However, because the blue wavelength is much faster, it's up and down a lot more, has a much higher chance of hitting one of these air molecules, the oxygen or the nitrogen, and that's why we see it kind of dispersed the way it does. We call this scattering. Rayleigh scattering is the technical term, but basically what's happening again is the blue part of that visible light is hitting those oxygen and nitrogen molecules in the air, and it scatters the light, and that's why we see blue. Now, if you go to a different planet, say Mars, for example, this will look a lot different depending on exactly what the makeup of the atmosphere is. It could look a lot different. That's why Mars, for example, looks more red in nature. But we can see our own red light here on planet Earth, and that is sunsets. We see some gorgeous sunsets. Here's a picture down in Roseville, Illinois, back a few days before Christmas in 2015. You can see the brilliant reds and oranges there. Man, those are some of the best photos that we get from you guys watching this video. So why do we see those colorful sunsets? So we kind of now add another step to that scattering process. So again, the light coming from the sun, it's made up of a rainbow of different colors, red, orange, yellow, green, blue, indigos. Not just, of course, those colors, but the shades of those colors as well. That's what we call that white light coming in from the sun. As it passes through the atmosphere, when it's straight up, it doesn't really interact with a lot of dust particles. It doesn't act with a lot of pollution. And so that's why we see it more blue. But as it gets closer and closer to the horizon, it has to shoot through more of the atmosphere. It has to go through more of the atmosphere. And so what's happening is the yellows, the greens, the blues, the oranges, it's starting to bounce off of those little molecules in the sky, the dust particles, the smoke. That's why, especially when you see wildfires in the area, especially in the western part of the country, when you see those big wildfires with a lot of smoke, we tend to see really colorful sunsets because all of this sunlight is being scattered by all those tiny little smoke particles. And the only thing that can really punch through all of that is the red. And that is why we see very colorful sunsets, especially of the red variety. So again, those are some of the common questions that we see. Rainbows are produced by the raindrops that are passing through the sky. They act like tiny little prisms that create those rainbows. We see the blue sky because all of the sunlight coming through our atmosphere, the blue part of the sunlight, that is bouncing off the oxygen and the nitrogen molecules. And then we, of course, see the brilliant, colorful sunsets because of the sunlight being scattered by all the different pollution, smoke, and the dust particles. I hope this answered some of your questions. Meteorologist Rebecca Coltman will be back with our next WeatherFirst Workbook coming up on Thursday, same time, 10:30 a.m., right here at Iowa News Now.